Hello, water managers. My name is Matt Fleming. I am part of the Water Management Systems Division at the Hydrologic Engineering Center. And then this is the second video for the HEC-HMS Real-Time Hydrologic Modeling presentation. In this video, we are focused on the meteorologic model in HEC-HMS and options that you should consider when using different setups for your SWMS forecasting. All right, let's jump into it. On this slide, you see a figure, and the figure shows you the Meteorologic Model Manager or Editor in HEC-HMS. And you notice there's different options for different processes within meteorology. You have shortwave, long wave, precipitation, temperature, wind speed, pressure, dew point, evapotranspiration. You do not have to choose different processes for all of these. You can set some to none if you don't need specific meteorologic variables. For example, if you're not using energy balanced snow, then you do not need to set shortwave or long wave radiation. You do need a couple of these options set. So for example, precipitation, you do need a precipitation method in order to generate a forecast using SWMS. Temperature is needed for certain options. For example, if you're using snowmelt, then you do need to set temperature. If you're using some of the evapotranspiration methods, you do need to define the temperature variable. And then finally at the bottom, if you're doing a simulation more than 5 or so days, you do need to include evapotranspiration because evapotranspiration is what the canopy method in HMS uses to pull moisture, soil moisture, from the ground. Oh, and then finally at the bottom of this figure, there's an option to replace missing. And currently in this view of the component editor, it's set to default. And what that means is if there is a missing variable, HMS will fill it in with a default value. So for example, with precipitation, the default value for precipitation is 0 inches of precipitation or 0 millimeters. For temperature variable, you do have to have a value for every time step. HMS will not arbitrarily use a value and fill it in. So if you have temperature set and you come to a time step with a missing value, HMS will stop the simulation and issue an error message to you, letting you know that the data is missing and you need to provide a value. All right, so what meteorologic options should you use? For precipitation, most of you doing SWMS forecasting are going to use the gridded method. And usually what this means is you're using Cumulus, you're downloading the look back grid set or the observed precipitation grids, and then a forecast product. Then you're using METView to process that information and combine it to have one consistent grid set that then is linked to the HMS model. Other options that you could consider are you could use the interpolated method within HMS. The interpolated method lets you choose different precipitation gauges, rain gauges, and then you can also use a bias grid and choose different options for interpolating those point values into a gridded product. Another option is you could use the specified hydrograph method in HMS. And what's powerful about this is you can use HEC METView to process the grids and compute subbasin averages for you. And then you would link those subbasin averages from METView to the HMS model within the CAVI model linking editor. And then those time series would be passed to HMS. HMS would use them to do the loss computations and then the unit hydrograph transformation. If you do use specified hydrograph, your run times will be much shorter. You'll lose some in the spatial variability of the precipitation, but if that's usually not a factor for you or your watershed, then you should really consider the specified hydrograph method. It will save you tons of compute time. I mentioned this earlier, temperature, it's only required for snow and some ET methods. So if you are doing snow temperature index or the radiation-based temperature index snowmelt methods, you do have to have temperature turned on. And then other evapotranspiration methods, if you're using gridded Hammond, Priestley-Taylor, Penman-Monteith, those you do need to have temperature specified as well. Just like precipitation, you have different options for temperature. You can have gridded temperature, so if you have historical and forecast information, then you would specify that as a grid set. You could use the interpolation option 2 within HMS. So if you have an elevation grid, your terrain model, and then specify a lapse rate, HMS will do the interpolation for you. And specify gauge. If you have different temperature gauges in the watershed, you can use those point values to estimate the temperature across the different subbasins in the basin model. And then finally, the evapotranspiration option. The two that I really suggest are monthly average, and then also the gridded or non-gridded Hammond option as well. Okay, grid set definition. If you're using one of the gridded methods for precipitation and temperature, you do have to have a grid set defined within the HMS model or project. I've gotten a number of questions over the years why, when folks look at their different grid sets in HMS, why do they see this data source option where my mouse is set to multiple record DSS? Really what that means is that you've linked this HMS meteorologic model, basin model forecast within a CAVI forecast run. And whenever you've done that model linking, this option is automatically set for you, so you do not need to change it. Just leave this alone. The data source will typically be multiple record DSS whenever you're using a grid that's then linked to output from METView. What you do need to focus on is consistent path names between HMS and METView. And what I mean by that is look at the A part in this path name. So the A part here is Standard Hydrologic Grid, is SHG, and then Russian River. You should make sure that the grid path name that you see in your METView alternative have the same spelling, same characters that you see in the HMS grid set definition. And then another thing to consider is if you're looking at different forecast products, when you go to Cumulus, if you look at the different forecast products, you're going to see a number of different options. For example, you're going to see the National Blend of Models NBM forecast data set. You'll see the WPC data set, the HRRR data set, and a few others. And if you do want to load those into a CAVI forecast, what I suggest is you have a different meteorologic model within HMS that uses those specific data products. It just makes it easier whenever you set up a forecast alternative. If you have one grid set that's being linked to National Blend of Model data set, another grid set that's linked to the WPC data set, and so on. And then what happens during a CAVI forecast is the CAVI is going to replace the F part path name to the path name using the METView key. And you can see this in the lower figure here. And this is the model linking editor. I have HMS selected as the model requiring input. It's taking input from a METView alternative named QPF-NBM, so National Blend of Models. And then if I hover my mouse over the location parameter, you notice that the F part, this key, 10, that is my METView alternative key. So this is the visual cue letting me know that information from METView is replacing the path name that was specified within the HMS standalone project. All right, so this figure on this slide shows you the monthly average evapotranspiration component editor. So each month of the year, you specify the monthly rate. So in this example, it's inches per month, and then a pan coefficient. You would have to define this information for each subbasin in the basin model. However, there is a global parameter table that allows you to copy and paste. So if you define this information for one subbasin and it's close enough, you can simply copy and paste it to other subbasins in the basin model. The one thing to realize about the monthly average evapotranspiration method is it's not accurate for specific events. It's close enough, and the computation is fast. It's really designed for longer term simulations. However, again, it's going to be the computation is going to be close enough. Also, with the gridded Hammond evapotranspiration method, gridded temperature is required. I mentioned this before. Values cannot be missing at any time step in the simulation time window. And then older versions of HMS required that the temperature data be available 1 day prior and 1 day after the simulation time window. That is no longer the case with HEC-HMS version 412. This figure highlights the importance of evapotranspiration and really what's going on behind the scenes. So let me set the picture here. This upper figure shows you the precipitation hydrograph for a subbasin. This middle plot shows you the moisture deficit for the subbasin. You notice at the very beginning of the simulation, the moisture deficit is at 1 inch. And then you notice there's a period of no precipitation, so the moisture deficit is growing. The watershed's becoming more dry. And then we have this precipitation event. You notice the moisture deficit decreases. We have not reached a saturated condition yet, so there's no runoff. So this bottom figure shows you the runoff from the subbasin element. And even though there's precipitation here, no runoff was generated because the moisture deficit was so large. This event only relieved the moisture deficit from about, 1.2 inches down to 0.6 inches. After this precipitation event, there was no precipitation for about 2 days, so the moisture deficit began growing again due to evapotranspiration. Again, the vegetation is removing water from the soil. Then we had another event here on February 17th. It was a rather large event. All the moisture deficit went to 0. The watershed became saturated, and then this is when the watershed began generating runoff at the outlet of the subbasin. Okay, so hopefully this slide shows you really the importance of using evapotranspiration within the subbasin element. All right, if you have any questions about our software or need some help, here's some resources on this slide. And stay tuned for the next presentation about the basin model in HEC-HMS.